Hi, here's the problem with the couple sitting around the table. And if I were to do this again, I should have just asked for two or three. I think just to make you draw the picture of two or three to get the idea, because that's how I did all these. If you start small and get big, it kind of makes sense and you see the pattern. But just starting right off at six, it's hard to see what could happen. So this one, I want all the males to sit next to each other and all the females. And a trick here too, a couple of people didn't notice that you actually do have a round table, which makes it more complicated. So if you have this round table, let's just start with two couples. So you have like man one, woman one is couple one, and man two, woman two is couple two. So you have these four slots around the table. So I'm just going to say, let's start with the man right here. So there's two choices for the first man. And then the second man, there's only one choice. And now the women go here, and there are two choices for the first woman and then one. So there should only be two times two, or four different arrangements of two couples around this table. And I mean, we could even list them, right? So it's like man one, man two, and woman one, woman two. Or you could have man one, man two, woman two, woman one. And why I say these is different because, for example, from the viewpoint of man one, to his right is man two, and to his left is woman one, which is different than this first case. We could have man two, man one, and then woman one, woman two, or man two, man one, woman two, woman one. And these are the four unique. And even if if I turn the table, I'd have to turn it a full rotation to get back to the same one again. So some of these you can just kind of tick it around one or two and get the same arrangement. But in this case, there's four. So I feel good, like, oh, it looks like two times two, and I just want to make sure. So I would go to three couples. So I'll make a little bigger table for them. Little problem with our table. So here's one, two, three, four, five, six. I'm going to put men first again. So three choices for the first man, two, one. Same thing for women, three, two, one. There's really no issues here. I mean, if I have to turn the table all the way around to get back to the first man up there. So it looks clearly like 3 factorial times 3 factorial. And in this case, what is that? 6 times 36. I'm not going to list every possibility, but definitely I believe it from the 2 case. And I can see here I have the same pattern. So to go to 6 then shouldn't be much of a stretch. I see what's happening, and so I know it has to be 6 factorial times 6 factorial. Okay, so that is that part. So while we're here, we might as well go to part B. I probably said too much, but in part B, I just want alternating couples. So if you do it with, again, I can think man one, woman one, so I have a space, space, space. And so how many choices do I have for the first man? It's two. And then for the first woman, two. And second man, one and one. So it looks like four. But the problem is if I rotate this table two slots, I have the same combination well, I have identical combinations at the table. So here's what I mean. I could have man one, woman one, man two, woman two, or I could have man one, woman two, man two, woman one. Now any other scheme I can come up with has already been repeated there. So if I just want to, I'm going to do something totally different, I could do man two, woman two, man one, woman one. But really, let's see, this is just a rotation of this guy, right? So if I rotate this guy around the table and put the other man at the top, it's man two, man one, woman one. So in this case, same with here. I mean, I could start with the man up top and then the woman, but in a rotation, I get the same thing. So by rotating like two seats, I have the same, this is the same as that. So I have to divide by two and cut off by turning the table 2, I'm getting another one that already exists. So I have the same idea as before, like I have 2 times 2, but now I have to divide by 2 because of the turn of the table. So now I just have 2 times 1, or 2. So I kind of get the idea, and then I would try again a little bit bigger case, the 3 by 3. And if you agree by that, then you can already see I'm forming a pattern. So here's 1, 2, 3, 1, 2, 3. So 3 choices for the first man, but then 3 choices for the first woman. 2, 2, 1, 1. So it looks like it's right, 3 factorial times 3 factorial. But the problem is now if I rotate to here, I get the same combination, and here, right? So if I turn it like 2 seats, I'm in the same order again, and another 2 seats, I'm in the have one of those orders again. So I'm going to divide by 3, because rotating that table gives me one of those iterations again. So it looks like then I have 3 factorial times 2 factorial. And again, maybe you thought of it totally different. I'm thinking about man, woman, and then, rotating, but maybe you had a different idea there. So if that makes sense for 3 couples, then I can kind of see what has to happen for 6 couples, right? I mean, it will have to be, I could keep building, but I know then it has to be that. And so I think I'll leave 3A and B, and maybe I'll leave 4s unless somebody wants a video. So if somebody wants to see 4, let me know. But the same way, I just started off small and started rotating. Start with 2, then 3, and then hopefully you see the pattern. So maybe I'll do one more, and then I'll just wait for people to let me know if they want others.